is going on inside. It is a surprise, right? It is a surprise to our grandparents that, acha fine, there are some devices which are available, which act like human. That's what there we are driving to that particular position nowadays, right? But the basic concept which is happening internally is to be noticed and observed, right? So that particular thing only we are going to study in the subject called computer or organization architecture. So when I say organization, again a simple definition. So KMIT organization which works with faculty, with head of the department, with coordinators, with students, with management, and so on. When all these come together, then it's called to be an organization. In the same way, there are a number of things which constitute together to form a system. We call that as a computer. And you build it in a particular way such that the instructions must go on hierarchically or sequentially or however it may be. There will be some process, right? That is called to be a particular design. That design is called as architecture, computer organization architecture. That is the meaning of the subject called computer organization architecture. Okay, so computer organization architecture. You are organizing a computer by building an architecture. Okay, so that's the main concept of this subject. And yes, coming back to our syllabus, so we have seen in unit 1 we are having 3 parts, and that's what we have discussed just before. So we are going to discuss about all these in the first unit, and so it's a basic concept of what a computer does and how a computer is going to work, and so on. Excuse me. And later, the second unit is consists of microprogrammed control, right? So in that microprogram control, what is going to control a system? What is going to control the commands? There must be something which gives a command, and a control must be there. As I told you just before, there is a control of your body called the brain, right? And so on. And next, when all these constitute together, they give you output by taking input. That means you are taking some data and you are manipulating the data. You have to represent the data in some way so that the system can understand. Like say for example, you are going to Delhi and you talk in Telugu, nobody understands. You come to you go to some London or something and talk in Hindi, who understands? No. There must be some representation of the data. There must be some translator or somebody who can translate the data and how to manipulate the data and so on. That is what the third unit, that is data representation. And using that data representation, you are going to give the input to get the output. That is what you are going to see in your fourth unit, input-output organization. Okay? And of course, after that, how the input can be reduced, or how it can be manipulated, and other things. Other things are going to be fifth unit, that reduced instruction set computer. So you don't need to get panicked. So it is we are going to cover all the topics one by one. Anyway, but to remind you, it is a theory subject where you will be getting some problems in the middle anyway. But almost 80% of the subject is theory subject. Okay, so that is about introduction to our particular subject. So I just want to, but starting with the unit 1. Okay. So unit 1, as I told you, the first part we're having the digital computers, introduction, block diagram of digital computers, definition of a computer organization, computer design, and computer architecture we are going to see. Well, so going into the subject now. I hope you all can view the PPTs which I am showing on my screen. Yes, so, what is a digital computer? So before that, what is computer organization? What is a digital computer? So computer organization is concerned with the way they are connected together to form the computer system. Right? The same example I have given you just before. I was talking about a human body. Right? A human body where you give some instructions and you have some particular thing which operates your particular different organs of your body. In the same way, different components. So here I don't need to again clearly explain what are hardware components, right? So computer organization is concerned with the hardware components which operate and the way they are connected together. So being constituted together to form a computer system. That's called to be a computer organization. Well, so exactly what is a digital computer? So here again, I suppose I have to again go back to some basics of computer, basics of computer. Frankly to say, you all know very well what are the languages we use for a computer. I hope in your first year you have learned Python, C, maybe basic or some other languages, or maybe some people have already have some grip on Java and some other languages. But is it that the system can understand all these languages? Certainly it's a no. Certainly a system cannot understand any other language except one language, that is machine language. Machine language is nothing but it constitutes of binaries, that is zeros and ones. That is why you call it as a binary language also. So binary language is the basic language which is understood by the particular system. Again, a simple example I give it to you. When you talk in Telugu, you can understand it easily. But when you talk in English, surely it will take at least a fraction of a second to understand more than Telugu. Why? Because Telugu is your mother tongue. And when you talk in Telugu, it directly goes into your brain. But when you talk in English, you need a translator which translates. Your brain accumulates the concept of translating your language, and then it translates to Telugu, get it into your brain, and again you understand it, and again what you want to speak back, or give me a you want to give me a particular response. Again you have to develop that in your mother tongue, and again convert it to English, and then it comes out through your mouth in English. So at least it takes a fraction of a second in between Telugu and English, right? That's what I wanted to say. Anyway, so in the same way, a digital computer, so you can say that machine language is the mother tongue of computer. I just wanted to give this statement. Okay. And what is that machine language? Nothing but zeros and ones. And again, if I talk about zeros and ones, they use binary systems, and where each and every binary digit is called to be a bit. So every information which we give to the particular system is being analyzed or represented in group of bits only, right? Okay. Now, so what is a computer design then? So computer design is concerned with the hardware design of the computer. How you are designing a computer, right? Once the computer specifications are formulated, it is the task of the designer to design it. Oh, I'm sorry, here I think that word is being deleted mistakenly. Okay. So when the computer specifications are given, the designer designs a particular computer system or computer design. So it is considered with the concern with the determination of what hardware should be used and how the parts should be connected, develop hardware for the system, right? So you have to, the particular person or the manufacturer engineer, he will decide of what hardware should be used and how the parts are to be connected for developing the particular hardware for the system, right? Next, digital computer. In digital computers, again you are having computer architecture, right? So what is the difference between computer design and computer architecture? So you are designing something, when you get a layout of it, it's called even architecture, right? You are designing something, you get a layout of it, then it's called an architecture, right? Or simply to say, a plan is called to be a design, right? And after designing it, you get an architecture, right? So you build a house, you plan something that my house must be like this, like this, like this, and after representing that particular design physically, then it's called an architecture. Okay, right. So in digital computers, basically we are having two types of architectures. So before that, yeah, computer architecture is concerned with the structure and behavior of the computer as seen by the user. So how the user wants, as I told you, right? How the owner of the house want to build his house, right? He plans it on a paper or whatever it may be, and it is represented physically, right? In the same way here, computer architecture is concerned with the structure and behavior of the computer as seen by the user. Next, so what does it contain? It contains or it includes information, formats, instruction set, techniques for addressing memory. So what is memory? What is addressing memory? Anyway, we'll go into that. That is what is the concept, one important concept of our subject. So how memory is used. What is memory and how it can be used and how it can be manipulated and so on. The number of things what we are going to study about that in our coming chapters and coming units anyway. But basically, you know what is a memory? It stores something. You all have memory. We all have memory. There is our brain, right? So brain stores something in the same way. Memory is there. So you feed the system with some data.
Amanika.
And the data is being stored in the memory. Time remains in the memory. When we are going to delete it. How it is going to be deleted. Those are again concepts of what we are going to see in our subject later. Forget about all those questions. What are you thinking in your mind anyway. So what I mean to say is, you are going to build an architecture that contains information and the formats and the sets. So what is instruction set, that also we will see. Okay, and techniques for addressing the memory. Yes. And so basically there are two types of computer architectures. One is the von Neumann concept or recorded as von Neumann architecture, and second is the Harvard architecture. So what is von Neumann architecture, we will see now. So von Neumann architecture, it describes the general framework or structure that a computer hardware programming and data is, right? And von Neumann is the person who have analyzed or described this particular architecture, which is being used by all the systems nowadays. Basically, so von Neumann is nothing but contains the following components, that is ALU, RAM, control unit, and man-machine interfaces. Right? So what is ALU? Arithmetic logic unit, RAM, random access memory, control unit, which controls your particular